I'm willing to give your company another chance, Julian. Boy, Shelley was rude and condescending. That's a big word for me. Ha ha ha.
Well, we appreciate you giving us a second chance, Bobby. I'm comfortable you'll find our discussion very worthwhile because the analysis is solid. It was just delivered in a less than ideal fashion.
I'm feeling more comfortable already. You're not giving me any scowling looks, texting your friends, or rolling your eyes.
Well, based upon the feedback that we've already received regarding Shelley, we are going to be reassigning her to a more detailed number crunching type of role, which she excels at. At times, we don't get the most glowing reviews when we send her out. However, she has very good technical skills, and we want to put her in a position where she can succeed.
That's great. Great to hear. So what's a linear regression model? Because it wasn't really clear from Shelley's explanation.
A linear regression model is a model that we can tend to use to predict the future based upon what's happened in the past. So premium organic dog food has excellent customer data. In spite of what the report said, the data was actually quite good. And we can use the data from the past to predict the future. We use historic observations of past customer behavior or inputs, or otherwise known as attributes, of their pets to predict something. In this case, how much a customer is likely to spend on pet food in a year.
Wow, that's great. Another question. Why are there two models?
Well, there really weren't two models. There was a kitchen sink model, which we ended up having to rerun because there was a row ID in it. But all the attributes in that model weren't necessarily giving us the best idea what's going to happen in the future. We've whittled the first model into a second model with better predictive capabilities and fewer of the previously used attributes.
Okay, sounds good. What are the inputs of the model?
Well, the kitchen sink model had more attributes and had most of premium organic dog foods customer data, such as the age of the customer, not the pet, but the customer, the number of dogs in the household, household income, how much the customer cares if the pet eats organic dog food or not, the cost of the dog, etc. The final model used the most predictive attributes, or the ones that gave us the best idea of what was going to happen in the future. And those were the organic rating, how much the customer cares about the organic rating of the food, and the cost of the dog as predictors of customer spend.
Okay, can you explain to me what the independent and dependent variables are?
Well, we just talked about inputs. So the independent variables are the attributes. It's easy to remember because independent and input both start with an I. The independent variables are what we use to predict the dependent variable, which is how much the customer is going to spend, which is really what you hired us for. The results of the kitchen sink model were tested to show how effective each independent variable is in predicting the dependent variable, how much a customer is likely to spend. This is the reason we don't use all the variables. Variables work for you just like employees might. So you want to use an employee that's going to get the most work done. It's the same thing with the independent variables, which is why we limited it to the two that were the most predictive.
What does the model tell me about my business?
Well, it really tells you what you hired us for. Given some information about each customer, which in the final model were the organic rating and the cost of the dog, we can try to predict how much each customer is likely to spend.
Wow, that is so much clearer. Thank you so much.
The pleasure is all mine, Bobby. Thank you.
Thank you.